When I was a kid, I had this strange idea. I thought, maybe God has made a mistake. Maybe when he was supposed to put my soul in my body, there was a mix-up. So he put my soul in my brother's body and my brother's soul in my body. And now we're living our lives in the wrong bodies. How do I know that this is my body? How can I be sure? So as a young man, I got interested in science, and brain science in particular. How does the brain create the conscious human mind? It's quite fascinating when you think about it. The brain, 1.5 kilo clump that you can sort of hold between your hands, 100 billion neurons, brain cells, that communicate with analog electrical signals. And yet everything you will ever experience, think or feel come from that piece of biological tissue. How is this possible? So I studied to become a brain scientist in Sweden, and then I went to London to learn more about advanced brain imaging technologies. But I never forgot this question I had as a child. How do I know that this is my body? Why does it feel like my sense of self is located inside this body, and I experience the world from this perspective? Well, some of you might say, what kind of strange question is that? Of course the self is in the body. Where could the self otherwise be? It's not like the self is leaving the body from time to time. Well, that's not entirely true. So when I was a medical student, I was doing my clinical rotations. I was at psychiatry and in the emergency ward. And I was interviewing a young man around 25. He was suffering from schizophrenia. And I was interviewing him. He was quite calm at the time. We were sitting in a small room, and there was also an experienced older nurse in the room. And when I was talking to him, suddenly he got quiet, just froze, stopped talking. And then the nurse stood up, I remember. She walks over, she takes the guy and starts to shake him like this. And I go, what's happening here? What's going on? And she said, from time to time, you just have to shake him to get his self back into his body. Because his self sort of floats away. He has out-of-body experiences. I got very curious. What's going on here? So when he started talking again, I asked him, what did you experience? What happened? And he said, well, I was just sitting, and then I saw you were talking to this other guy, and then I saw the nurse came up and started to shake that guy. So he had this experience that his self had left his body, moved to another corner of the room, and there he was looking at himself from this new perspective, like he was looking at another person. And I thought, what's going on? What's going on in this guy's brain? What is happening in my brain now when I have sort of a normal in-body experience? So I decided I want to do experiments. I want to understand this more. But in science, if you're going to study a system, how the brain gives us a sense of a bodily self, we need to have a way to perturb that system. So how do we take a normal test person, bring him or her to the lab, and change that person's sense of bodily self? Well, we use something called perceptual illusions. These are mind tricks that allows us to study how the brain interprets sensory information. So this is one illusion we discovered in my lab a couple of years ago. So you're the test person, you're sitting in front of a table, and you put your hand on the table, and there's a screen that occludes the hands, you can't see it. Then the scientist is using 2 small paintbrushes and is stroking your hand and a portion of empty space like this. In the beginning, it's really boring. I mean, nothing happens. You just sit there, someone is stroking your hand. But then after 15, 20 seconds, in most cases, something strange happens. You can see that in the participant's face. Their eyes open, their mouth open, they start to giggle. Suddenly, they start to sense touch where they see the paintbrush moving in empty space. And they lose awareness of the real hand, and they start to experience that they have an invisible hand straight in front of their eyes, an invisible hand that senses the touch of the paintbrush. So here we have created some kind of out-of-body experience for the hand. We have pulled out the sense of the hand from the real hand to empty space. And so this tells us that for the brain, this is a very dynamic process. It's like the brain can interpret and change the experience of your own body, and And it also suggests that might be something very important about how the brain interprets what you see and what you feel. Now, people are not making this up. This is not just people just not being imaginative here. You really feel this invisible hand. And we can test that by attacking the hand with a hammer or a sharp object. And then we can see if people respond with a fear reaction, just like if we attack the real body. And we can measure that because people sort of sweat. And we can measure the increase in moisture of the skin by putting 2 electrodes on the skin. And we can see that they react in the same way like when we threaten the real hand. And it turns out that this illusion obeys very precise rules, like scientific rules, you could say. So you have to apply the strokes in the same directions. Different directions, there's no illusion. You have to apply the touches simultaneously. If there is a delay, if it's asynchronously, then there's no illusion. And it only works within space close to the test person, within reaching distance. So what we think is going on here is that the brain is integrating, putting together what you see and what you feel into one coherent representation of your body. So we call this multisensory integration. So the brain puts together what you see, what you feel, and information for the muscle sent, and creates a coherent representation that this is my body. But can we take this further? So now we did an experiment with a hand. Can we use the same principles to create an illusion that someone completely leaves the real body, an experience like an out-of-body experience? So we try that in another illusion experiment that we designed. And now you're the test person, you're sitting on a chair, and now you wear head-mounted displays. It's 2 screens in front of your eyes, and they are connected to 2 cameras that we put 2 meters behind you. So you see yourself through the back. And then I touch the test person's chest, and then I move my hand towards the cameras. So I'm synchronizing the touches like this. So now something very strange happens if you're the test person. You start to experience that you're outside your real body, that you're sitting a couple of meters behind yourself. And you're looking at yourself, you know it's you, but it doesn't feel like you anymore. It feels like another person. But you have to do that. You have to apply these touches simultaneously. If it's out of sync, it doesn't work. So this is a breakdown of the illusion. There's a tactile stimulation on the person's chest. There's a visual stimulation towards the cameras. If it's synchronous, you feel the illusion, you're outside your body. If it's asynchronous, you don't have the illusion. And again, we can test this by attacking the person with a hammer like that. And now we are attacking the sort of conscious sense of self, bodily self, that is now sitting 2 meters behind your real body. And people react with fear response. If we attack the person's real body, then the person don't care. It's not scary because the self is not in the body anymore. So, but can we take this further? Can we give people a sort of body swap illusion? So we took the self out from the real body. Can we now give the mind a new body? Would that work? So we have done experiments like that. So now we put the cameras on the head of a mannequin pointing down, and you wear the head-mounted displays. And when you look down, you see the mannequin's body, to the first-person point of view. And that's important. It doesn't work if you look at the mannequin like you look at another person. And then we do this synchronized stroking. So we touch the mannequin and your body at the same time, same direction, corresponding body parts. And now, boom, you just feel that the mannequin's body is you. This is your new body. It doesn't matter if you're a man or a woman, or the color of your skin, if you have clothes on. You just feel that the mannequin is you. And it works with any human body. So just think about that for a moment. So your brain are willing to accept any human body as your own body. But it has to look like a human. It has to have a human body plan. It doesn't work with things that doesn't resemble a human, like a large lobster, for example, or a table or a block of wood. But if we obey the basic rules of the body illusions in terms of time and space and a humanoid body shape, then it works with very large bodies, 4-meter giants, or very small little Lilliputs. So we have done experiments where you feel that you are like a 30-centimeter little doll, like Barbie's friend Ken. And then we do the synchronized stroking on the little doll in your real body, and you wear the head-mounted displays. And now you feel that you are that little doll. And it's a very vivid illusion. And now you're living in the world of giants. You see these gigantic hands, and people look like giants. You know this can't be happening, this can't be true, but it just feels real. It feels like it's your body, and it has profound effects on how you experience the world around you. So what's going on in the brain? So this is the brain, this is the front, this is the back, this is the top of the brain. And here we're taking the brain and inflated it so we can see the surface a little bit better. Back here in the brain, we have the visual cortex. Information from our eyes reaches that part of the brain, helps us see. And then up here we have the somatosensory cortex. Information from muscles and skin and joints, touch, sense of touch, reaches that part of the brain. And then we have these areas, the brain's integration zones, the frontal and parietal association cortex. And these areas, they can receive visual information and somatosensory information and integrate these signals and create a coherent representation of that this is my hand. Now, when you then sense that yourself is located in a particular place, we think that there's another part of the brain that is important, in the so-called temporal association cortex. And in this part of the brain, last year, there was a Nobel Prize awarded for the discovery of so-called play cells. These are cells that keep track of where a rat is located in a little cage. It's like the brain's GPS. And we think that in humans, this area keeps track of where your sense of self is located in the world. So how do we test this? This is an hypothesis, right? How do we go on and actually do experiments? Well, we use this fantastic thing called brain imaging technology, brain imaging techniques. So here we're using functional magnetic resonance imaging. So it's like a big tunnel. You go into that tunnel, only your legs are sticking out, and we can create images of the brain activity in healthy people by strong magnetic fields and radio waves. So we can register brain activity at the resolution of 2 by 2 by 2 millimeter cubic voxels. The signal reflects changes in the oxygen level of the blood, because when brain cells work, they use up oxygen. So now when you went into that tunnel, you're the test person, you're going into the tunnel, and you wear the head-mounted displays, what you see is the scanner room from the perspective of a stranger that is lying in the corner of the scanner room. And then you see that stranger being stroked, and you feel touches on your own body at the same time at a corresponding place, right? So now we are scanning the out-of-body illusion and the body swap illusion. So you don't feel that you're in the scanner anymore. You're feeling like you're lying on the floor on the scanner room and that you have a new body, a stranger's body. And the scanner is collecting data all the time. And now we can teleport your sense of self between two locations in the corner of the scanner room, the right corner and the left corner. So every 10 seconds, you're in one corner, and then you're teleported to this corner, back and forth. All the time during this out-of-body illusion, all the time we're collecting brain data. So first we looked for which areas that give you a sense that the stranger's body is your own body. And we found increases in activity in these frontal and parietal association cortices that integrates what you see and what you feel. It gives you a sense of ownership of the body. And then we looked for activity that reflected the sense of self-location, the sense of where you're located in space. And we found that this particular part of the medial temporal cortex, where play cells were finding rats, activity there reflected the conscious sense where your self is located. What have we learned? Well, we have learned that when we have a normal in-body experience, there's two systems in the brain that are working in concert, working together. There's one system that is saying, hey, this is your body, by integrating what you see and what you feel. And there is another system that keeps track of where your sense of self is located in the world, with respect to environmental landmarks in the environment, that says you're located exactly here. And if these two systems are working properly, interpreting the information properly, you have a normal in-body experience. But if the brain is not working properly, if you experience an out-of-body experience, for example, or you have a brain disorder, or you haven't slept well, or you're tired, and these things are not working properly, then you can have an out-of-body experience because the information is not integrated properly. So how can we use this? How can we use this to improve human health and make our everyday life easier. I think that there's a number of important applications. Now, first of all, it can give us a new understanding of what is going wrong in major psychiatric and neurological disorders where there is a disturbed sense of self and body perception. For example, in schizophrenia, there are 50 million people in the world that are suffering from schizophrenia, and disturbances in the sense of self is part of the core symptoms, and we don't know what is causing it. So we can now do new experiments to try to understand better what might go wrong with the sense of self in schizophrenia, maybe to develop better diagnostic tools or therapeutic tools. But we can also use our knowledge about how the brain creates the sense of our bodily self to project the sense of the self into artificial devices. And I think that we are almost on a verge of a scientific revolution where scientists, mind scientists, brain scientists, engineers, and robotic people can work together to use this in a number of different applications. For example, to create a new generation of artificial limbs for amputees that feels exactly like real limbs, so that amputees can feel a whole again. And also maybe use the prosthesis more intuitively because it feels like a real hand, for example, in the case of an upper arm amputee. We can also improve today's applications in virtual reality and project the sense of self into computer-generated avatars so that in virtual reality you have a full-blown illusion, body swap illusion, that the simulated avatar really is your new body. And that can increase the realism and immersion in today's application, in games, for example. Or we can project the sense of self into advanced humanoid robots so that you get an illusion that you are now the humanoid robot. When you see and feel through the body of the robot, and when you move, the robots make the same movements. And that could be very helpful. For example, if an engineer is supposed to control a humanoid robot in rescue work, say they're going to fix a nuclear power plant, it could be easier if you just teleport your sense of self into that robot and you can react very quickly, very intuitively, very fast. So I think we have a lot to learn from science and brain science and technology to improve people's health and make our lives easier. Thank you very much for listening.